If the variance of Poisson variant is 3, find probability that x equal to 0, 1 less than or equal to x less than 4, 0 less than x less than or equal to 3. So in the question, luckily the distribution name is given. Whenever name of the distribution is not given, we have to identify which distribution it is. But here, luckily Poisson distribution given. In Poisson distribution, we all know that in Poisson, variance is lambda. Variance is lambda, that is given. Variance is lambda. In Poisson, mean equal to variance equal to lambda. And also in Poisson, probability of x is e power minus lambda into lambda power x by x factorial. This is formula to calculate any probability. E power minus lambda into lambda power x by x factorial. Now coming to our first bit, for x equal to 0, find probability that x equal to 0. That means we need to calculate probability at x equal to 0. That means in this, write in the place of x 0 and write in the place of lambda 3. So what you will get? E power minus 3 into 3 power 0 by 0 factorial. That is e power minus 3, because 3 power 0 is 1, 0 factorial is 1. 0 factorial is 1 and anything power 0 also 1. Then what happens? E power minus 3 value, you need to use your calculator. So use your calci to get that value. E power minus 3 is 0.498. 0.0498. Use your calci so that you will get whatever the value you will get e power minus 3 in our calculator. Note down that. Next, p of 1 less than or equal to x less than 4. That means starting from 1 less than 4. That means less than 4 means 3 up to 3. So starting from 1, 2 and less than 4 means 3. So probability of 1 means, this is the formula, e power minus 3 into 3 power 1 by 1 factorial. Probability of 2, e power minus 3 into 3 power 2 by 2 factorial. Probability of 3, e power minus 3 into 3 cube by 3 factorial. 3 power 1, 3 power 2, 3 power 3. Write in the place of x3 in this formula. Write in the place of lambda 3. Okay. Now what you will get? E power minus 3 common. 3 plus 3 square 9 by 2. 3 cube 27 by 6. 3 factorial is 6. And calculate these values. Enter these values in your calci. You will get the answer 0.5974. Use your calculator. Now coming to the third bit, probability of 0 less than x less than or equal to 3. So here 0 less than x means in reverse x greater than 0. Greater than 0 means starting from 1, 2 and equal to 3. So probability of 1 means again the same one, this one only, right? Both are same. If you repeat the same process from here, you will get the same answer, like 0.5974. Clear? Any doubts you may ask? 2% of the items of a factory are defective. Defective. The items are packed in boxes. What is the probability that there will be 2 defective, at least 3 defective in a box of 100 items? So for that, what we need to find? We need to find probability that 2 defective. In a factory, 2% items are defective. 2% are defective. That means probability of defective is 2%. 2% means 0.02. Very small value, 0.02. 2 by 100. 2 by 10 means 0.2. 2 by 100, 0.02. So here, given P is very small and N contains 100 items. If you observe, this is a very small value and which is a large value. When P is small, N is large, we will convert given problem into Poisson distribution. We will convert binomial distribution problem into Poisson distribution problem. How to convert? By finding mean. Actually, problem is in binomial. In binomial, mean is NP. What is N? 100 into 0.02. Actually, P is 2%. 2 by 100. That is that one. So 100 into 0.02 you will get 2. So in Poisson, mean can be taken as lambda. So in Poisson distribution, one parameter is enough to find any probability. Lambda is enough to find any probability. So now we know lambda. Now we are going to find the remaining probabilities. First one, probability of 2 defective. That means we need to find P of 2. In Poisson, we all know probability of x is e power minus lambda into lambda power x by x factorial. In Poisson. So actually the problem is in Poisson distribution. So we need to apply this problem. We converted given binomial distribution problem as binomial because P is small, N is large. Large means more than 20 we can consider as large. 100 is large, 500 is large, 1000 is large. In that cases you need to do the problem in Poisson distribution. Now probability of 2 means here in the place of x you are having 2. Lambda value you know. So substitute e power minus 2 into 2 power x. 2 square by 2 factorial. So what you will get? 2 e power minus 2. Probability of 2 defective. So 2 e power minus 2 or 2 by e power 2. Use your calculator to get that value. The value is 0.2706 is probability of 2 defective items. Coming to the next bit. At least 3. At least means less than or equal to. Minimum 3, maximum as many as possible. So here the question is at least 3 defective. At least 3. At least means, remember, greater than or equal to. That is P of x greater than or equal to 3. Because this is Poisson distribution, n is too large. Excuse me. N is too large. N is 100. So if you want to calculate P of x greater than or equal to 3, you need to add probabilities from 3 to 100. Is it possible? Possible, but it takes much time, very difficult. Then we use indirect case. 1 minus P of x3. If you have here greater than or equal to, make it less than. If you have here equal to, don't write equal to there. If you don't have equal to here, write there equal to. X less than 3 means 3 cases you will get. P of x equal to 0, x equal to 1, x equal to 2. So 3 cases. P of x equal to 0 means e power minus lambda into lambda power 0. In this formula, write in the place of x0, in the place of lambda 2. So what you will get? e power minus 2 into 2 power 0 by 0 factorial, e power minus 2 into 2 power 1 by 1 factorial, e power minus 2 into 2 square by 2 factorial. So take e power minus 2 common. What you will have? 2 power 0 1, 2 power 1 2, 2 square 4. Then 2 square by 2 you will get 2 only. 2 square by 2 factorial is 2. So finally 1 minus 5 e power minus 2. You have to use calci, no alternate way. So if you calculate, you will get 0.323 is the probability of getting defective, at least 3 defective. Probability of getting at least 3 defective. Any doubts you may ask anywhere. The average number of accidents on any day on a national highway is 1.8. Determine probability that the number of accidents at least 1, at most 1. Average number of accidents. That means mean is given. No information we have in the question. Only one parameter we have. Only that parameter is mean. You don't have n, you don't have p. Then with one parameter, which distribution can evaluate any probability? Like that you need to think. For Poisson, only one parameter, that is lambda, is enough to calculate any probability. If you take binomial, it requires n and p, minimum 2. Here we don't have n, p. We have mean. Along with mean, if you have p, you can find n. Along with mean, if you have n, you can find p. But we have only one information, that is lambda value only given. Mean is given. In such a cases, you need to treat this one as Poisson distribution problem. Now, by assuming the given distribution is Poisson, in Poisson, we take mean as lambda. Here given lambda is 1.8. And in Poisson, probability of x has formula e power minus lambda into lambda power x by x factorial. This is formula to find any probability in Poisson distribution, and we know lambda value. Lambda value is enough to find any probability. Now coming to the first one. At least 1. At least means greater than or equal to. Minimum 1, maximum as many as possible. That means probability of x greater than or equal to 1. X greater than or equal to 1 means starting from 1 to, we don't know n, how many values we have to take. In that case, go indirect way. Do it in indirect way, in indirect method. 1 minus p of, if you have here greater than or equal to, write here less than. 1 minus p of 0, x equal to 0. Here write in the place of x0, in the place of lambda 1.8. E power minus 1.8 into 1.8 power 0 by 0 factorial. If you calculate this value, you will get answer 0.832. Use your calculator. So coming to the next one, at most 1. At most 1 means greater than or equal to, at most 1, right? At most 1 means less than or equal to 1. At most, maximum 1, minimum as less as possible. At maximum 1. That means p of x less than or equal to 1. X less than or equal to 1 means two cases. P of x equal to 0 plus p of x equal to 1. 0 case and 1 case. That means e power minus 1.8 into 1.8 power 0 by 0 factorial, e power minus 1.8 into 1.8 whole power 1 by 1 factorial. If you take e power minus 1.8 as common, 1.8 whole power 0 is 1, 1.8. Calculate using your calc this value. If you calculate 1.8 power 0 is 1, 1 plus 1.8, 2.8. 2.8 into e power minus 1.8 or 2.8 by e power 1.8. If you type, you will get 0.46. Use your calc. Use your calculator, whatever the value you will get, note down that value. Okay? Any doubts you may express. In Poisson variate, one relation is given. 3 into p of x equal to 4 equal to 1 by 2 p of x equal to 2 plus p of x equal to 0. Using that relation, find mean, that is lambda, and probability of x less than or equal to 2, that means p of 0 plus p of 1 plus p of 2. So clearly here Poisson distribution given, and using this relation we need to find the lambda value first. So we all know that in Poisson probability of x is e power minus lambda into lambda power x by x factorial. This is formula. So now by taking given condition, we are going to evaluate lambda value. What is given? 3 into p of x equal to 4 equal to 1 by 2 into p of x equal to 2 plus. So 3 into p of x equal to 4. In that formula, write in the place of x 4. If you write in the place of x 4, what happens? E power minus, we don't know lambda value. Lambda power 4 by 4 factorial equal to 1 by 2 into e power minus lambda into lambda square by 2 factorial plus e power minus lambda into lambda power 0 by 0 factorial. So see here, 3 into e power minus lambda into lambda power 4 by 4 factorial is 4 into 3 into 2 into 1. 4 into 3 into 2 into 1. 24. Coming to here, you can take e power minus lambda common. So what is left over? 2 2s are 4, lambda square by 4 plus 1. 0 factorial is 1, lambda power 0 is 1. So e power minus lambda cancel. What is left over? 3 1s are 3 8s are. Okay. So here what you are having? Lambda power 4 by 8 you are having. Here if you take 4 LCM, lambda square plus 4 by 4 you are having. 4 1s, 4 2s. So lambda power 4 equal to 2 lambda square plus 8. If you evaluate that one, lambda power 4 minus 2 lambda square minus 8 equal to 0. So lambda power 4 can be written as lambda square whole square. So lambda square whole square, that means this is a quadratic equation in lambda square that can be evaluated using factorization formula. Some methods are there. What I am saying, lambda power 4 into 8 lambda power 4. If you take 8 lambda power 4 factors, you need to get the difference or sum 2 lambda square. 4 2s are 8, 4 minus 2, 2. So I am writing lambda power 4, 4 lambda square plus 2 lambda square minus 8. So if you take here lambda square common, lambda square minus 4. If you take here 2 common, lambda square minus 4. So here again take lambda square minus 4 common, lambda square plus 2. Now lambda square minus 4 equal to 0 or lambda square plus 2 equal to 0. This becomes not real number because lambda square minus 2, lambda equal to root minus 2, which is not real. So we won't take this value as lambda value because lambda is mean. it should be a real, especially positive. Lambda square equal to 4, lambda plus or minus 2, root 4. But lambda is mean. That's why mean is always positive, never be negative. Lambda equal to 2. So first bit, mean of x is evaluated. Next, probability of x less than or equal to 2 means probability of 0 plus probability of 1 plus probability of 2. So in this formula, write in the place of x0 in the place of lambda 2 first. Next, write in the place of x1 in the place of lambda 2. Next, write in the place of x2 lambda 2. What you will get? E power minus 2 into 2 power 0 by 0 factorial. E power minus 2 into 2 power 1 by 1 factorial. E power minus 2 into 2 square by 2 factorial. If you take e power minus 2 common, 1 plus 2 plus 4. So 2 square 4, here you will get 2 only. So 5 e power minus 2 you will get. So calculate using your calculator, you will get the answer 0.6275 like that, 6765. Okay, use your calculator. Fit a Poisson distribution to calculate theoretical frequencies. That is, fitting distribution means finding expected frequencies, already given frequencies. For that, we need to calculate theoretical frequencies or expected frequencies. For that, so to find the expected frequencies or theoretical frequencies, we have one formula. Theoretical frequencies will be calculated like this. Capital N into P of x. Here capital N is sum of frequencies. Sum of frequencies means you need to add total frequencies. That you will get 200. You can check using calci. Now we need mean. Because this is Poisson distribution, we need lambda to find any probability. To calculate probability of x. We need lambda value. Lambda is nothing. In Poisson distribution, lambda is mean. Whenever data is given like this, x and f, the formula to calculate mean is sigma fx by sigma f or sigma fi xi by sigma fi, where I is from 0 to 4. Here also I is 0 to 4 fi. Now this value will be calculated like this: 0 into 109 plus 1 into 65 plus 2 into 22 plus 3 into 3 plus 4 into 1 by sigma fi is 200. So if you calculate that numerator value using your calci, you will get 122 by 200. Then calculate again using your calculator, you will get its value 0.61. If you get lambda value, that is enough to find any probability in Poisson. So now we are going to find all probabilities like this. Taking x values which are given 0, 1, 2, 3, 4. Taking x values, finding their corresponding probabilities and multiplying that probability value with n, which is a theoretical frequency. This is theoretical frequency. Theoretical frequency, which is asked in the question. Theoretical frequencies. Theoretical frequency we can get like this. N into P of x. So now P of x has formula e power minus lambda into lambda power x by x factorial. So this is the formula which we need to apply. E power minus lambda into lambda power x by x factorial formula. So using this formula, one can evaluate all the values. Here capital N we know 200 capital N. This is the formula which we are going to use to calculate probabilities. So now first probability. So here P of x formula is this one, e power minus lambda into lambda power x by x factorial, because this is Poisson distribution, that's why. So 0 means right in the place of x0 and right in the place of lambda 0.61. P of 0 this is. X equal to 0 means P of 0. P of 0 is e power minus lambda minus 0.6, lambda 0.61 by 0 factorial. Lambda power 0, 0.61 whole power 0. Like that here, e power minus 0.61, 0.61 whole power 1 by 1 factorial value. E power minus 0.61, 0.61 whole square by 2 factorial value. E power minus 0.61, 0.61 whole cube by 3 factorial value. Using this formula, for 4, e power minus 0.61, 0.61 whole power 4 by 4 factorial value. Like this we need to calculate all the values using calculator. Simply type that values in your calc, you will get the answers. Simply type that values in your calculator, you will get the values like probability of R values. After multiplying this value with this, after finding this value, multiplying with 200, you will get 108.7, which can be taken as 109, and 66.3 and 20.2, 4.1. After multiplying with 200, 0.7. Generally, we approximate that value with its nearest integer. So 108.7 can be taken as 109, 66.3 can be taken as 66, 20.2 can be taken as 20, 4.14 approximately equal to 1. They are theoretical frequencies. These values you need to calculate using calc. If you multiply that value with 200, what I am saying, here you will get e power minus 0.61. This becomes 1, this becomes 1. This value is e power minus 0.61 into 200. So here also 0.6 into e power minus 0.61. If you multiply this value with 200, you will get this. Here also multiply this one with 200, you will get this. Multiply this one with 200, you will get. Multiply this one with 200, you will get 0.7. So they are theoretical frequencies for given pre-expected frequencies. These are theoretical frequencies we got. 24.1, which are closer to actual frequencies. Very close to actual. This is the procedure for fitting a binomial distribution. If 0.8% of fuses delivered to an company are defective, use Poisson approximation. In the question itself he said, use Poisson approximation to determine the probability that 4 fuses will be defective in random sample of 100. So here, if you won't mention Poisson distribution also, the problem is in Poisson, because n is large, p is very small. When p is very small, n is large, binomial distribution tends to Poisson, we know that. But here in the question itself, he said use Poisson approximation. So first, I am writing given p, the defective items. Defective items probability. So defective items probability is given 0.8%, which is 0.8 by 100, 0.008. So here P is 0.008, which is so small, very small value, and n is given 400, which is large value. Whenever p small n large, binomial distribution tends to Poisson distribution. So here mean, in Poisson mean, lambda equal to, in Poisson mean is lambda, that will be calculated by multiplying n and p. So what is n? 400 into 0.008. So lambda value you will get, use calculator, you will get 3.2. Now we need to find a probability that 4 fuses defective in sample of 400. So to find any probability in Poisson, probability of x has formula e power minus lambda into lambda power x by x factorial. E power minus lambda into lambda power x by x factorial. This is the formula in Poisson to find any probability. But our case is P of 4 we need to find, because probability that 4 fuses defective. The number of fuses defective is 4. That means we need to write in the place of x 4 and in the place of lambda 3.2. So write in the place of lambda 3.2 and write in the place of x 4. If you calculate this value using your calculator, you will get probability 0.1780. So this is the probability of getting 4 fuses defective out of 400. Out of 400 items, if you select few items, you can find 4 items only defective with probability 0.17. That means 17% probability for getting 4 defective. So at a checking counter, customers arrive on average 1.5 per minute. Find the probability that in any given minute, at most 4 will arrive, exactly 4 will arrive, at least 4 will arrive. So first, if you read the question, you can understand in given data we have only average. Except average, you don't find any other parameter. Only one parameter we are having. So with one parameter, with one value, we need to find probabilities. So with one value, one parameter, we can find probabilities in Poisson distribution only. We cannot find probabilities in binomial. Binomial distribution requires minimum 2 parameters. What are they? N and P. But here NP is given. We can find N or P if we have any other N or P value along with NP. Mean is NP in binomial. So by reading the question, what you can understand, in given data we have only one parameter. In that case, we prefer Poisson distribution to find probabilities. So for this problem, we are going to use Poisson distribution because we have only one parameter. In Poisson, so mean we represent with lambda, that is given 1.5. And also in Poisson, probability of x, to find probabilities, e power minus lambda into lambda power x by x factorial is formula. Using this formula, we need to evaluate these all. We know lambda value. So coming to the first bit, at most 4 will arrive. At most, I said so many times, at most, at least. At least means greater than or equal to 4. Minimum 4, maximum as many as possible. At most means maximum 4, minimum as less as possible. Maximum 4. That means less than or equal to. These things you need to remember. Exactly 4 means equal to 4. So first case, we need to evaluate probability of x less than or equal to 4. So So probability of x less than or equal to 4 means we need to start from 0. Probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. Up to 4. So probability of 0 means in this formula write in the place of x0 and replace lambda by 1.5. If you do like that, e power minus 1.5, 1.5 whole power 0 by 0 factorial plus e power minus 1.5, 1.5 whole power 1 by 1 factorial plus e power minus 1.5, 1.5 whole square by 2 factorial plus e power minus 1.5, 1.5 whole cube by 3 factorial plus 4 e power minus 1.5 into 1.5 whole power 4 by 4 factorial. For first case I written in the place of x0, in the second case I written in the place of x1 for p of 1, for p of 2 we written 2, for p of 3 we written 3, p of 4 4. So if you observe in every fraction you have e power minus 1.5, you can take it as common. Anything power 0 1, 0 factorial is 1, so in the first one you will have 1 only. In the second one you will have 1.5. In the third one 1.5 whole square by 2 factorial 2. In the next one 1.5 whole cube by 3 factorial 3 into 2 into 1 6. Last one 1.5 whole power 4 by 24. 4 into 3 into 2 into 1. 4 factorial means. Now if you calculate this value using your calculator, you will get a value of 0.9814. Approximately 98% chance to get 4 customers in 1 minute. Okay, so now coming to the next one. That is second bit. Exactly 4. Exactly 4 means P of 4. So in this formula, you need to write in the place of x4 in the place of lambda 1.5. What I am saying, write in the place of lambda 1.5 in the place of x4 by 4 factorial. 4 factorial is 24. If you type as it is in your calculator, you will get probability that exactly 4 will arrive in 1 minute. 0.047. So here exactly 4. This probability to get exact 4, but here there is a chance of getting 0 customers also. For getting 0, 1, 2, 3, 4 together we have this much of chance. In 1 minute if you have 0, that comes under this case only. 1 this case, 3 this case, 4 this case, but here 100% 4, correct 4 customers. There is very less chance. If you multiply this one with 100, only 4%. So coming to the third one, at least 4. At least 4 customers means, I said, probability of x greater than or equal to 4 we need to find. Probability of x greater than or equal to 4. If you know n, then you can find out greater than case very easily. But we don't know n. That means greater than or equal to 4, okay. Starting from 4, how many values we need to add? We don't know. Because Poisson distribution, n is too large. N may be infinity also. So in all Poisson distribution problems, for greater than case, you need to apply indirect case. That is like this. 1 minus P of. If you have greater than or equal to here, make it less than. If you have only greater than, keep here equal to. If you have greater than or equal to, write there less than only. Don't write equal to. X less than 4 means 1 minus less than 4 cases. P of 0 plus P of 1 plus P of 2 plus P of 3. This you need to calculate. Exactly this one only. excluding this part. You need to write these three. 1, 2, 3 up to here. This one, this one, this one, this one. If you write here and subtract from 1, you will get 0 point something value, 0.0658. 0.0658 is probability of getting at least 4 customers per minute. It has also very less chance, that is 6% into 100 if you do that. So here what you need to do, 1 minus these 3 from here to here. If you write there, you will get up to 4 I written. You need to write up to 3 using this formula. Okay? Any doubts you may express.